Okay, this is Mr. Peterson, and I'm going to be teaching you how to solve equations involving exponents and logarithms. And this is Algebra 2, Section 6.6. So we're going to start with the exponential versions. And in this section, you'll learn how to, first of all, isolate the base and the exponent that's on it. And then you're going to learn how to rewrite the equation so that base goes away, and that'll then open it up for you to solve for x. Okay, so the first step is to isolate the base and its exponent. So let me show you that on this first example, and just so you're clear on what we're trying to do, the base here is 4, and that exponent is 3x. We got to get that part of the equation isolated, in other words, by itself. So in this case, you're going to try to strip off the times 2 and the plus 6. And you always go in the reverse order that PEMDAS would have you work in. When you're solving, you go backwards on the order of operations. So first we'll subtract 6 from both sides. And then we'll clear that times 2 by dividing both sides by 2. Okay, now at this step, at this stage, you're going to try to get rid of that base of 4. And once you get the base and exponent by itself, you always take the logarithm using the same base that's already in the problem. So logarithm base 4 is how you get rid of this. And that has to be done on both sides. So what we have here is a case where we're going to cancel. Hang on, let me get this set up here. We're going to cancel that logarithm and the base. Those are canceling action. Log base 4 and a base of 4, they cancel each other off. So now you end up with just 3x equals log base 4 of 7, and dividing by 3 will get the answer for you. Now you'll notice also that I plugged it into my calculator and came up with a decimal estimate. Now there's one more step that's not written here. I'm sorry, it is written here. It says you need to check your work. And that's especially important in this section because there's extraneous answers that appear to work but really don't. So the way you're going to do that is you're going to store this value on your calculator for x, and then you'll type this left side just like it looks, and it should equal 20. And this one does check, so we're done. We've got a legitimate answer, and we can move on to the next part here. Okay, on the other side, we've got, on example 2, we've got to get rid of the 5 that's in front here. It's in the way of this base and exponent. So the part we're trying to isolate is that base and that exponent. And in this case, we'll have to divide both sides by 5 to start out with, which gives you a fraction. Not very convenient, but you can see that by dividing by 5 and dividing by 5, I've got my base and exponent isolated. Then you take log base 4.2 on both sides. Now that happens to be the same base that we already had, and that's a canceling action over on this left side over here. This log base 4.2 and this base of 4.2 are canceled off by that action. And on the next line here, you simplify how it's written down, but really I didn't make any changes there. And I've got one more step. I'll add 3 to both sides. There's also the step of typing it into your calculator and getting the decimal estimate. Once you have that answer, you're going to store that as a value of x. And on this problem, then you would type 5 times 4.2 to the x minus 3 power and see if it really does give 8. And this one is a legitimate answer. So once you've checked it, you know you've got the right answer there in this problem. Okay, we'll pick up in the next video on page 2.